Let's start with law one. Law one tells us that if we have a to the power of m multiplied by a to the power of n, it is going to give us a to the power of m plus n. Okay. Now, what is the use of this law? Let's assume, for instance, we have 2 to the power of 4 multiplied by 2 to the power of 6. The first thing we're going to check is, are the bases the same? Now, if the base is the same, then the law can apply. It becomes 2 to the power of 4 plus 6, and that gives us 2 to the power of 10. This is the answer. Okay. Now, for law 2, if we have a to the power of m divided by a to the power of n, it is going to give us a to the power of m minus n. That is, if I had 5 to the power of 4 divided by 5 to the power of 2, now so far the bases are the same. We could apply the law. It gives us 5 to the power of 4 minus 2, and that gives us 5 to the power of 2. This is the answer. Okay. Now, for law 2, okay, this is law 1, this is law 2. Now, for law 3, if we have a to the power of 0, it is always 1. Anything to the power of 0 is 1. Alright? Yes, anything to the power of 0 is 1. So we have 5 to the power of 0 is 1. 10 to the power of 0 is 1. 1 billion to the power of 0 is still 1. Now, for law 4, if I have a to the power of n multiplied by m. Now it's like having a power into a power. Okay, this is a power and this is a power. What does it give to me? It gives me a to the power of mn. Hmm? So if I want to apply this law, let's assume we have x to the power of 2 all into 3. This will give us x to the power of 2 times 3 is 6. Okay. Now, how about law 5? Law 5 tells me that if I have a to the power of, let's say I have a times b all to the power of n. What does it give to me? It gives me a to the power of n times b to the power of n. Okay. Now remember that these laws are reversible, so you can move just as you can move from here, just as you can move like this. You could also move in the opposite direction. Take note. In all the laws, you could reverse them. Okay. Now, if I had if I had a to the power of n over b to the power of n, this could be this is 6. This could be a over b all to the power of n. Now 7. If I have if I have a if I have okay, let's say I have a to the power of negative n. Okay, this gives us, because of this negative sign, this is saying 1 over a to the power of n. Okay. Now number 8. If I have a to the power of n over m, it is the same thing as the mth root of a all carrying a power of n. Okay. Yes. So now let's assume I want to apply these two laws. Okay, let me apply these two laws here. Now let's say we had 4 times 5. Okay, 4 times 5 to the power of, okay, 4 times 5 to the power of x. This can be written as, applying this law here, this could be written as 4 to the power of x times 5 to the power of x. Now, if I had 6 to the power of negative 4, it is the same. If I wanted to apply law 7 here, it's same as saying 1 over 6 to the power of 4. Okay. Then, if I wanted to apply law 8, if I have 4 to the power of 3 over 2, what this means is square root, because this is 2, this is 3 over 2. The 2 at the base here simply tells us square root. So it becomes square root of 4 all to the power of 3. Now what is square root of 4? Square root of 4 is 2. So it becomes 2 to the power of 3. That gives us 8. Okay? This is law 8 being applied. Now, if I wanted to apply 6, let's assume that we have x to the power of 2 over y to the power of 2. Now, if I wanted to apply 6, this is the same thing as saying x over y all to the power of 2. Okay? This is it. Now, there is a rule that we call the isomorphism rule. Okay? The isomorphism rule. Now, this rule tells us that if you have a to the power of x being equal to a to the power of y, so far the bases are the same. Okay, we could have that x is equal to y. In the same way, if I have x to the power of 1 over x is equal to a to the power of 1 over a, it simply tells me that x is equal to a. Okay,